When we have a mixture, it can be separated very easily using physical changes. There are several ways to separate a mixture. Some of these methods are more appropriate for different situations. The first and the most common type of separation technique is filtration. The best situation to use filtration is when you have a heterogeneous mixture of a solid in a liquid. Most typically, you'll have an experimental setup where you have a funnel, possibly being held by a ring stand or inside of a flask, some type of filter paper that has holes that are small enough to catch the particles of whatever the solid is and allow the particles of the liquid, usually water, to pass right through. This separation technique is the best one to use when dealing with heterogeneous mixtures of a solid in a liquid. Distillation is the second type of separation technique that we can use. When we have a homogeneous mixture of two liquids that have distinctly different boiling points, distillation becomes the most appropriate. By heating the mixture of the two liquids, we can cause one of the two liquids that has a lower boiling point to boil, condense, and be caught in a separate container at a different temperature. The substance that has the higher boiling point will be left over in this flask on the left. Distillation is best used when you have two liquids that are mixed as a homogeneous mixture, but they have very different boiling points. The third technique is crystallization. Crystallization is most useful when trying to separate a homogeneous mixture of a solid in a liquid, and usually that liquid is water. This technique is typically used when you have a salt, some type of salt, whether it's NaCl or another type of salt, that is mixed in a homogeneous mixture with water. The heat that's added causes the liquid water to evaporate. The water is not what we're trying to separate. We are trying to separate it from the salt. We're not trying to keep that in our mixture. So the water leaves, and whatever the salt or the solid was slowly starts to crystallize at the bottom of our container. This technique is best used in a homogeneous mixture of a solid in a liquid. The last separation technique is very specialized. It's called chromatography. Prefix chromato, color. Chromatography relies on differences in two substances. Usually they're mixed together as a homogeneous mixture that have different levels of attraction to a stationary phase. Most times when we work with chromatography, we rely on differences in the colors that are brought about by a mobile phase. When we do chromatography in the lab, it's usually a special type of paper that we're going to use. This paper has a line where we put a small sample of the mixture of the things that have different colors. The mobile phase, which could be water or it could be some type of rubbing alcohol, is placed at the bottom of this piece of paper, and it carries the compounds up the piece of paper. Then we can see, depending on the distance that the colors traveled, which of these colors had a higher attraction to the paper. Colors that move the farthest aren't really attracted to the paper very much, whereas colors that move only a small amount of distance have a higher attraction for the paper. This works really well for things that are very brightly colored, such as the pigments in leaves. You can also perform this in the gaseous phase. Gas chromatography uses differences between substances moving through some kind of a gas. These 4 techniques are going to come up in a few labs that we're going to do, but that should give you a summary of the 4 primary ways in which mixtures can be separated.